Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If today is your first time of visiting this channel, please try to subscribe and share. Okay. Also, we are done with the mathematical induction. We want to look at proof by contradiction. So we have a lot of ways of proving things. Okay. A question like this is given: prove that root 2 is an irrational number. If you want to do something like this, the best method of doing this is use proof by what? Contradiction. Are we good? So how do you use proof by contradiction? If you want to use proof by contradiction, we know that indeed root 2 is an irrational number, but we will contradict ourselves by saying that let's assume that root 2 is rational number. I hope you know what irrational number and rational number is. We all know that rational numbers can be expressed in fraction form. So the first thing to do is this. We know that you say assume that root 2 is what? Rational number. Okay. This we are contradicting that. Okay. We know that root 2 is never a rational number. So if we do that, it means that this is the assumption that I've stated. So if I'm able to prove this wrong, that means I'm able to contradict this. Do you understand that? So if I'm able to prove that this root 2 is irrational, then the proof is done. So what I'm going to do next is that if root 2 is a rational number, so I can, it means that root 2 is equals to a over b, because we know that rational number can be expressed in what? Can be expressed in the fraction form, where b is not equals to 0. Because immediately this b goes to 0, it becomes what? Undefined. And also a and b are irreducible. Let's take note of this. A and B are irreducible, means that you can't reduce them. It means that the common factor exists between these two is 1. If I'm able to prove to get a common factor existing between these two to be, let's say 2 or 4 or 3 or whatever, then it has contradicts my initial condition. Or the initial condition is saying that A and B is irreducible, means that it has a common factor to be 1. If you have something like 3 over 5, this has a common factor of 1, so that is irreducible. Is that okay? Very good. So let's move on. So let's take this one. Root 2 equals a over b. So let me square both sides. This gives you 2 equals a squared over b squared. Now let me make a squared the subject. That gives me a squared equals 2b squared. Let me name this one equation 1. What is going to happen? Look, a squared equals 2b squared. It means, so the idea here is that I'm trying to prove in a such way that I will know that I'll get the b to be a to be even number and b to be even number. You know, when I have two even numbers, it will have a common factor. Like if I have 4 over 6, this is two even numbers. This will have a common what factor. So if I'm able to get a and b to be even numbers, then I'm good to go, because per what I said, it means that a and b can is not reducible. But if I'm able to do it in such a way that it will be reducible, then I'm good to go. So let's see. So after getting this, I can confidently say that a squared is even. The letter a squared is even because a squared is equal to 2b squared. And remember that every number 2 is a factor of every even number. So if I give you 4, 4 has a factor of 2. If I give you 2, 2 has a factor of 2. If I give you 6, 6 has a factor of 2. So since this 2 is multiplying the b square, I can say that a square is equals to 2b square, which is making the a square to be even. So if a square is even, then a is also even. Do you agree with that? Yes. The reason is that you know that this a square is the same as a times a. Remember that even times even number will give you even number. Is that okay? It means that this a is even, this a is even. So if a square is even, a is even. So if I have like 2 times 2, I'll get 4. It is even times even, 4. 4 times 4, I'll get 16. Even times even, I get 16. But if I have 2 odd numbers, like 3 times 3, 3, 3, 9. All of them are odd, right? So let me move to something. So we are able to prove that a square is even. Now let me also get to see if I can get b to be even. Now, if a is even, it means that what is going to happen is that a is equals to 2m. Now, where is this m coming from? If a is even, then I can assume where m is an integer, okay? I can assume that this m or any integer times 2 will give me even. So because you know that even numbers have 2 as each factor, every even number. So any integer times 2 will give me even. So I can also define a to be equals 2 times any integer. All right. If that is the case, because I want to come and substitute a here, but here is a squared, so I have to square both sides to get the a squared. So if I square here, then I'll square here. Have my a to be 4m squared. Here is squared. Let's name this one equation 2. So you put equation 2 into 1. So if I do that, this is equation 1. A squared equals 2b squared. Okay. The idea is that I have to also get b squared equals 2 times a certain integer. Okay. So if that is the case, by a squared is 4m squared equals 2b squared. So let me divide both sides by 2. That will give me b squared equals 2m squared. Now I realize that b squared is also equals to 2 times a certain integer, which means that b is also even because 2 times any integer is an even number. So b squared is what? Even. And b is also even. Is that okay? Now look at what is happening. We said, so this is why we call this contradiction. We said that root 2 is rational, which is equals a over b, right? And you realize that the a over b is irreducible. Something that is irreducible. Yet, we are able to prove, it means that this and that cannot be even. So if I'm able to prove this and that to be even, it tells me that there will be a common factor apart from 1, a common factor of 2, which is reducible. Have you seen that? So I'm contradicting what I said here. So therefore, I can say that per my contradiction, which shows that this is now becoming reducible per what I've proved that b is even, a is also even, then by contradiction, so it states by contradiction root 2 is not equals to a over b, or you can say that root 2 is not is what, an irrational number, because for irrational number it's never equals to a over b. Irrational numbers cannot express in fraction form. So this is how you do contradiction. Thank you very much for watching.